All right. Hello, everyone, and welcome to this new series, Learn Everything About Autodesk Insight. Last month, we had our kickoff of the series, and I really enjoyed it, like many of you today. And today is the second episode. I'm Jed Dalal with Customer Success Organization, and I will be your host today. My guest speaker for this series is Ian Molloy. He's a senior product manager in Revit's team and responsible of Autodesk Insight. In this series, you will learn about integrated multidisciplinary design and how Autodesk is applying it to buildings for better outcomes. You will hear directly from Ian from the product team. You will get today tips and tricks to increase your productivity, and you will discover practical examples of using this smart tool. We'll have this in our next episode and even more from Ian. This presentation, for your information, will be recorded and posted in the EP Hub. I will be sharing the link, and you will also get this link to the recording, the follow-up email you are receiving from us, I think, next week. Please use the Q&A section to ask your questions related to the topic, and use the chat window to share feedback or any comments you have. We will make sure to answer most of your questions today, but we can follow up with the unanswered questions. Now, let's try to use the chat window. So please type yes if you attended the first episode and no if you didn't. Perfect. Thank you so much for those, for the new ones who attended, and for those who attended the second one. So perfect, it's working perfect. So yeah, please use the chat window to comment, to share feedback, and the Q&A just for technical questions. So I can see two yes on the Q&A. So it's only for technical question. Perfect. Thank you so much, guys. And with that, I hand over to Ian, and the floor is yours, Ian. To you.
Thanks, Jed. Yep. Can you hear me okay?
Yes, I can hear you.
Okay, great. So thanks again for organizing this, and thank you everybody for joining me. I see there's a mix of people who joined me the last time and some new people as well. So everybody's welcome. This episode is episode 2, tips and tricks. I'm just going to very quickly recap episode 1 so that you know something about what we talked about the last day. It was generally an overview introduction to Insight, to talk about why is it important, the relevant industry trends and so on, and ultimately what Insight really is, which is essentially a subscription feature within Revit and AEC collections that provides integrated energy in building environmental performance analysis in the form of energy, daylighting, solar radiation, and heating cooling load calculation. We also talked about how it's different, and that it's a sort of fundamentally different paradigm, that there's many, many tools that do this type of thing. But we've really tried to take a different approach with this and really integrate it as part of the design process and really make it BIM-based. And in that regard, you'll see there's some differences to it in terms of being, entirely BIM-based, a single model, being the kind of thing that you can do on every project, and really engaging many more stakeholders, not just the engineer, the specialist, but also architects and even the client. It also spans the whole design process, and also critically, we'll talk about a lot today, that lives in this paradigm of direction and accuracy over single point precision. So we'll talk more about that. I also provided a demonstration and covered some frequently asked questions, and if you happen to miss it, as Jad said, you can pick it up at the Enterprise Hub, along with a lot of other great videos and content as well. Just search for Insight and you'll find it. Okay, so let's get started on tips and tricks. So here's an outline of what I'm going to cover. Basically, I'm going to start with the basics, just to make sure, if you don't have the software installed and things like that, it's not going to work. So I'll spend a couple of minutes on that. And then everything else is sort of in a workflow order. I'm going to start with, the most basic thing around setting the location and the relevance of that around climate data. And then just very briefly touch on solar analysis. And the reason I do that is that it utilizes the climate data as well as the energy analysis heavily. And there's just a few little pointers that are worthwhile highlighting there. the main part of this presentation is around the energy optimization piece. So we'll cover all the Revit side, energy settings, how to create the energy model, and then Insight itself, exploring the results and the data, creating reportage. And then finally, I'll give you a pointer to some more references around daylighting. We should probably have a whole session on the solar and daylighting alone. And then hopefully I'll have time for some questions and answers. So that's basically an outline of what I'm going to do. So in terms of basics, you want to make sure that you've got Insight installed, and as I mentioned last day, it is installed with Revit. Just sometimes it's not enabled in Revit. So the first thing to do is just, if you go into the File menu and click on Options under the User Interface, if you scroll down, you'll see the Energy Analysis tools. Just here, you want to make sure that they are enabled, and then once that happens, you'll see that it appears under the Analyze tab under the panel Energy Optimization, which contains all the tools for creating the model, sending the analysis to the cloud, and the energy settings, and looking at the results and so on. So that's, once you've got that, you're ready to go. The other part of Insight beyond energy around lighting and solar and so on comes as a plugin. So if you don't already have it installed, you can download it. So just go to insight.autodesk.com, and you'll see in this area here under support download, you can download the version that you need for whatever your version of Revit is. Notice we're just about to post the 2019 version. So if you're already on 2019, just give us a couple more days and we'll have that for you. And then finally, just check you have the entitlements for this. So if you go into manage.autodesk.com, you should just look down and you'll see these three: Insight Energy, you'll also see Green Lake Studio, and Lighting Analysis. That's just the way they're captured here. You'll get all three. If you don't have them, you won't be able to run it, and you just need to speak to your system administrator. Purely for purposes of lighting analysis only, you'll want to check that you have cloud credits and that they're linked to the same account that you're signed into Revit with. And remember, I mentioned the last day, you'll only use those cloud credits if you go above a certain size of analysis, and you're told in advance about that. So you can do lots of lighting analysis and that for free. You only use your cloud credits when it gets to a certain size. But to just be able to use the feature, you need to be able to have the entitlements in place and be aware of your cloud credits and make sure you're signed into the right account. So they're just common things that trip people up right out of the gate. So I thought I'd mention them very quickly. So with those three things in place, you're ready to go, and we can get started. So the first thing I'm going to start with is really just setting the location. I always say, do this first, because you only really need to do it once, and once it's done, it's set, and you can move on. But it has a very important role in a lot of the things that we do. There's a number of places in Revit to set it, but within Insight under Energy Optimization, you'll see just purely set the location. That will open up the location dialog, and you can enter your location at any sort of level of detail, either like a town or a city or even the exact address. It will find it, and then what you're presented with is a series of weather stations around, in the area. Each weather station essentially contains hourly data for a full year, and it includes air temperature, humidity, wind speed, and wind direction, direct and diffuse solar radiation. That's for a full 8,760 hours in a year. That's what an energy simulation uses. That's what the solar analysis uses, and so on. So some of the tips to watch out for this is that if you look at the IDs inside these, there's a little number here, is that there's really two types of climate files that people use in analysis. The most common type is what are called typical meteorological years, or TMYs. They're basically the average over the last 10-year period. They're the most average each month taken over a 10-year period. So it's real data essentially assembled, and the fact it's an average, it's a good use for simulation. And you'll see that they all start with a 5.9. They have a little ID, so anything with a 5.9. So if you see one of them near your location, it's a good idea to pick that. If not, all other locations refer specifically to 2004 and 2006. And you might ask why that's the case. It just happens to be data that we have sourced and made available to you, and where TMYs really only relate to big cities across the planet. This is literally at a 15-kilometer grid almost everywhere on Earth, so that you can get climate data for analysis pretty much anywhere. So it's very valuable to be able to do that. So with those three in place, we can move on into solar analysis. Is one of the I wanted to cover this because there's a couple of things here that people often overlook or get tripped up on, and I also wanted to touch on how it uses the weather or climate information. So the first type of, if you're going to explore solar analysis, the type of study I would recommend is the solar energy annual PV, because if you pick that one, it's kind of an automated push button thing, because what it will automatically do is select all roof surfaces in your model. And all you need to do is, so just check that that's the right one that you have picked, and then click on update. And what that will do is that will run the calculation for the full year and calculate the incident solar radiation and PV energy production, and then give you the graphic of where the insulation on the roof surfaces are. The little tip I wanted to give here was, if you look at those little cogs of settings here, and these values in here, this is all to do with things like the electricity cost and the panel efficiency and the percentage of coverage of the surfaces that you have selected, as well as the payback. And essentially, you'll see they're mirrored in Insight, so that when you're looking at total building energy and the contribution of PV to the total building energy, you can actually coordinate between the two of these, meaning the solar analysis can do the kind of the detailed study, surface by surface, or even down to panel by panel type detailed panel design, and Insight can track that as part of the overall total building energy contribution. The next thing to note about this, and it's just another common thing that sometimes trips people up, is that the solar radiation calculation is using, real climate and weather information, meaning it varies hour to hour and day to day. The example I wanted to give you is this. So, for example, if we just isolated this study to the 21st of September, you'd see that for this particular surface we've selected here, there's 836 kilowatt hours. Now, you would think that, in normal terms, the amount of sun, typically on 21st is based on solar position alone, 21st and 22nd would be essentially very, very similar. I mean, there's going to be a very small difference between them. But because the weather can be different, and that's what's in the climate file, you'll actually see that the 22nd has a lot more cumulative insolation. And that's visible if you actually dig in and look into the climate data. What this actually is the 24-hour period on day one, and that's 21st. This is the 22nd. And this is the global horizontal radiation. You can see there's a lot more of it. It's a lot sunnier day on the 22nd, meaning you get that. So it's just worth bearing that in mind if you're looking at solar radiation, over any period. It's always worth remembering that it can vary at any particular time. So, for example, on your location, if you pick, it's common to look at days like 21st of June or 21st of March. They're not always the sunniest days, so it's just worth bearing that in mind. And it's always worth looking at longer periods and cumulative insolation and things like that. So that's just one of the common things that is worth being aware of and how solar radiation works. And then finally, this even trips me up from time to time. When you're using the custom analysis and you are picking the surfaces in your model, like if you pick that roof, you'll get a little dialogue that explains to remind you to do this, but very often you turn it off and then you forget about it. But when you select that surface, you'll see up on the dialog box, you'll see you have to click finish to finish the selection. You won't be able to click update until that's done. And sometimes people are wondering why update is grayed out. Just make sure when you're finished selecting your surfaces, just click finish, and then you'll be able to click update. That's one of the common things that trip people up. So just some very simple tips on solar analysis there, just based on our experience with people using it, things they commonly overlook or aren't familiar with, and it'll just help with you using the tool for the first time and getting value out of it. So now I'm going to shift to talk about energy optimization, and I'm going to start with the Revit energy settings. Now, throughout all of these, we've set the defaults to be to essentially cover you. So if you aren't sure about any of these things, the defaults are generally, if anything, will do more than you need. So, but it's worth being aware of these, because in certain situations, you might want to more advanced use, you can sort of refine or optimize your workflow a little bit more. The first one to be aware of is under energy settings, you'll see a mode, and there's 3 different modes to pick from. And my tip is that always use what's called the Conceptual Mask and Building Element mode. People often get confused here because they think, well, if I've no conceptual masses in my model, only building elements, I'll use the building element only mode. That's actually not the case. This mode will use either or any mix. And at this stage, it's more advanced than the other modes, and it can account for more complexity. So just regardless of what you've got in your model, even if it's conceptual only or building element only, always use that mode. And that is the default in new Revit projects. But if you've got an older Revit project and you open it up, it can sometimes be set to one of the older modes. So it's just the very first thing to check, just make sure you've got that mode set. The next thing to do is, again, this is the default, but start with the default, what we call analytical space and surface resolution. You know, the energy model creation is automated. There's an entirely, proprietary algorithm behind that. We invested a lot of time and effort in working on that, and it works on this basis of essentially of voxels. And this analytical space resolution is essentially, it's the resolution of that grid that we analyze the building, the analytical model geometry on. And I always recommend starting with the default. You can reduce it later, and you'll see the benefit of doing that later, but always just leave them as they are to begin with, because you'll see later in the workflow how we can actually, sometimes you don't need to reduce them, sometimes you do, and it's worthwhile understanding the incremental steps that it takes to get there with them. The next setting that sometimes confuses people is perimeter zone depth, as to whether to use it or not. Now again, by default, it's on, so if you're not sure, just leave it on. But what this basically does is, essentially, depending on what you've modeled, it will add a certain additional level of zoning around the perimeter core to make sure the building volume is subdivided so that it simulates properly. And the advice here is, for example, if you're at a massing stage or you've like no internal walls, then yes, absolutely, because it will subdivide the interior building to make sure it captures the distribution in energy use throughout the building. If, however, you're at a detailed stage and you've got, an interior modeling, I won't just say interior walls, because it's not to do with the interior function in Revit of the walls. It's just whether you have elements inside the building that are dividing spaces, or in energy terms, zones separately. And if that's the case, you don't have to turn it on. You'll make your model a little bit more efficient and run a little faster. But like I said, if in doubt, just leave it on, leave it yes. And 15 foot is the recommended default. That's basically a best practice approach in energy modeling terms. Then the next one for the advanced options, the first one to be aware of is building type. So if you look down at advanced and you see in here in building type, people often get stuck in this one because they think, well, what if I've got mixed use and things like that? And in reality, this actually has one of two effects, but one is really all that matters in Insight's context, and that is the fact that it's what influences the benchmark comparison in Insight. So in Insight, where you see the little dial going red, orange, or green, that's the point at which it passes the ASHRAE baseline or the Architecture 2030 baseline, and that is dependent on building type. So that's the impact that has. It does also affect, things like the schedule and things like that of the building. But remember, because Insight varies all of those inputs anyway, we can turn whatever is in the model into something else in Insight very easily. So you're really only setting it for the benchmark. So it's worth being aware of that. Next, there's the room and space data, and again, by default, the default is rooms, and they have sort of no effect on the model. And it's worth noting that to create the energy model, you do not have to have room or space objects, those little 2D objects present in the model. Remember, you can create a model from a conceptual mass or just 4 walls, a roof, and a floor. You don't have to add a room or a space. It will identify that there is a room or a space in there, or what we call an analytical space. If they're there, however, it will add certain data to the energy model. And in the case of rooms don't really add anything other than room names, and it doesn't do anything with them. It's just if you were to open up the model, the Gbxml or the DO25, you'd see what was there. But if you use spaces, however, and spaces are present in the model, spaces have essentially building type information at the space level, which is occupancy, lighting, equipment, schedules, and so on. So you can get very prescriptive on a space-by-space basis, what's actually happening inside the building. But the point is, you don't have to start with that from the outset. But if you are planning to use spaces, then you need to change that to, use spaces, and then that information will be reflected in the Insight simulation. And then finally, I highly recommend you do this first time. A lot of people get tripped up on this. If you go to the advanced settings, always check that to begin with, that the detailed elements are disabled. Sometimes people, either on older model templates, or people go in and enable them because they think they need them in there. It's often a problem, because what happens is when you tick that, it will use all material thermal properties found in the model and all the elements and layers. And if you're not confident, if you didn't set them, or you're not confident about all of them, it can create some weird situations, like, for example, a metal stud wall, which has 4 inches metal stud. If that metal has metal properties assigned to it, the energy simulation will interpret that as 4 inches solid metal, and that's obviously massive thermal mass, and it will cause instability and cause the thing to fail. So before you go adding any enabling that or adding any thermal properties to the model, just be clear about what you're adding and how Revit interprets them, and you can check all of the help for that. But again, to begin with, you don't need to worry about that, because remember, Insight is going to vary all the roof properties, wall properties, glazing properties for you, and you can understand what role they play, and then later on come back and start to detail that information in the model and use it. So they're basically all my tips for energy settings in Revit, and you can think of them as a checklist. You can go through them very, very quickly, and once you've done that, you're essentially ready to create the energy model. Okay. So what I'm going to go now is go through my tips, or the really steps for creating an energy model. I'm going to give you an overview, and it might seem like a lot, but I'm actually going to then show you live how it actually works, and I'll show you how in about 5 or 10 minutes how I can create an energy model from within Revit. So first, I'm going to start with the overview. The first thing I would say to anyone, again, for beginners, start simple. And this isn't because we can't deal with complexity. It's just it's easier to learn when you start with something simple. And I would suggest you start with masking and levels, because the reason is easy. Why would you start with something like this at a very detailed stage when you can start here, just masking and levels? You can do a reasonable approximation of the building shape and form and massing and so on. You can automatically create the model from that. It will do automatic perimeter core zoning, percentage glazing, all best practices for energy model creation. This is really fast. I mean, really, really fast. It takes minutes to create these models. It's very simple. It's also very accurate. And as I said, it's great for learning, not so much just on the energy model side, but really on Insight and the range, UI and things like that. And it gives you a very valuable thing to bring to a project team and start to do targeting and feasibility right from day one. And then, of course, that can obviously help inform detailed design. So if you've done that early on, or even if you've got a detailed model, a conceptual version can be a good QA check against the detailed model. So it's good to have them in parallel. I often use the example that, if somebody was asked the question of if you sloped this wall in or out by 15 degrees, that's a very difficult operation to do in Revit. It would take a long time for you to do that and then analyze it. Whereas to do it in a massing model is very, very quick. And because you can actually put the same amount of window to wall ratio into this model from this model, you can actually get a pretty good steer on what impact that 15-degree change in or out can have. So it's good to have both, and it's good to learn that way. So it's just my first recommendation. Walk before you run, explore some massing, especially if you want to learn about Insight more. When it comes to the energy model creation, let's get stuck into that now. Okay. So if you take any random Revit model that you haven't seen before, I get lots, every other day to help people learn this. And I've developed just a step-by-step process. This is covered in the help, but I'm going to give you the actual sort of live example of it here. But here's the first thing you do, right? So first of all, create a new 3D view and isolate the key architectural elements used in the model. So just go into visibility and graphics and basically disable everything except these elements here. And you'll see that these are all the key architectural elements, like walls, floors, roofs, windows, et cetera, right? What you get then is you get to see what the energy model algorithm is going to see, okay? And it's not because Revit, the energy model creation is not created from a single view. It's created from all elements in the model, not just the view. The purpose of the view is just to enable a quick visual check. So once you isolate those elements, you take a quick visual check to say, is the model reasonably enclosed? We're not looking at every tiny little gap. We wouldn't be expected to see that. It doesn't require that. It's just, is there a roof on the model? Is there a floor on the model? Is there any large openings, that are going to cause a problem? I'm going to show you this. This next step is optional, but I recommend it for faster processing, and I'll explain why. But basically, just disable any unnecessary elements. Often Revit models have like walls and floors sitting out in space. Maybe someone's used a floor for some landscaping or something like that. Because they have no impact on the energy simulation, or it's not part of the building, I would just suggest selecting them and set them to non-room bounding. And this is the reason why. If you look at all the elements in that model and imagine a bounding box around it, and then if we were to disable them, you'd see you'd have a smaller bounding box around them. And because the way the algorithm works, because it's voxel-based, it's proportional to the power of 3. It's cubic, right? Meaning that if, for example, the red box was 10 units of volume and blue one was 5, in other words, the red one was twice as big as the blue one, then because it's cubic, that's 2 by 2 by 2, meaning the blue one will be 8 times faster than the red one. So just making that simple change will make the algorithm run much faster, use less memory, and it's just a nice step, to help with that process. So then the next thing is just to do an initial visual check for large gaps or missing elements. Remember, this is not, I talked about this the last day, you're not, this algorithm expects there to be, you know, reasonable small gaps and overlaps in the model. It's highly tolerant of that. But when they get above a certain size, really to the point where there's something serious missing in the physical model, you need to address them, and there's different ways to do that. I'm just going to show you an example here, and an example I'm going to show you of like what's a large gap versus a sort of a small gap. You'll see here, this sort of cut out piece here, that's a large gap, right? There's something missing there. You'd need to address that. This, on the other hand, where you see this small gap, where that floor and that wall, those two floors don't quite meet and there's no wall, that's probably going to be okay to ignore. Remember, we're not trying to find everything. The algorithm is going to point them out for us, but it's just, there's no point in running it if there's something obviously missing from the building, and you can just do it first. The general rule here is that large gaps are basically greater than 1 to 2 times the analytical space resolution. So if you've got a space resolution of 1.5 feet, you're talking 1.5 feet to 3 feet is a large gap. And think about that. That's a fairly major missing piece of the building. It's not asking for you to do anything particularly onerous on the model. And in fact, doing all of this tends to lead to a better physical model in the first place. Okay, so that's that. Then once you've done that initial check, you know, it's basically create the model, and what you do is you check the model's sort of completeness, right? You check, you know, where there are spaces and the surfaces cover the extent of the building. Now, you're not expecting a perfectly watertight energy model, the same way as that the architectural model does not have to be watertight. The energy model does not have to be watertight. What you're looking for is that it captures, you know, roughly, 95% or more of the building's volume, its floor area, and all its surfaces. And that's something you can actually do just visually. You don't have to measure it, and I'm going to show you that in a minute. So the way to do that is, the first thing to look for are these things we call surface type shades. So if you go into your view, and then again, this is a tip, set that view to mechanical and go into analytical model categories and enable analytical surface type shades. And this is what you'll see. And in this particular model, you see, yeah, look, all these shades are all in the right place. That overhang, this parapet, they're all correct shades, but why are these shades here? So there's something missing here. And if you actually look at that model, you see that roof is actually not set to room bounding. Because sometimes, you know, you might see the roof, the algorithm doesn't see it. So therefore, you just need to set that to room bounding, and it'll fix it. The next step with that is then just to check the overall extent of all the analytical surfaces. So all you need to do is here, for example, look at exterior walls, fixed windows, and operable windows. They're some of the main elements that you really need to take care about. And in this initial version of the model with the default resolution, you'll see that there are some large gaps between here. Now, in the energy simulation, that's not going to cause air leakage or anything like that. It's just going to underestimate the surface area of the wall for heat transfer. And this is beyond what I would find acceptable, right? This is below the 95% threshold. This is maybe more like 80%. It's close, just not fully there. And so, yeah, and you can see the gaps that I'm sort of pointing at there. And so this is where the resolution setting comes in. So if you go and change the resolution, and I would always suggest do it sort of incrementally, but when you get to this kind of 8-inch, 4-inch point, I find the sweet spot. It's kind of fuzzy logic, so it could be 9 and 5. You get very, very similar results. I generally keep them as a 2-to-1 ratio. And what you'll see then is that you'll get much tighter model. It won't be perfectly tight, but it'll definitely be above 95%, or in other words, within a couple of percent of the physical measures. So you check the extent. But then when you increase resolution, you also need to make sure that you haven't introduced or haven't found any other gaps in the model. And notice here, all the shades look to be in the right place now. We don't have them in the roof anymore. But this roof area here seems to be appearing as a shade when it shouldn't. And if we then take a closer look at the physical model, if you actually look underneath here, you'll actually see that there's a big gap in the roof. And all you need to do is fix that, and you get the model will then resolve itself. So that might sound like a lot, but it literally is just 5 steps, and I'm gonna walk you through it now so you actually see it. And I'm going to start from scratch and do it live. And what I'll say is that, every model is different. You'll find different conditions in different models, but the steps are the same, okay? So I'm already starting with step 1 done here, where I've created this separate view, and I've got my visibility graphics. I've disabled everything except the key architectural elements, okay? And the first thing I'm going to do is I'm going to pick these elements that I'm not interested in the model, and if they don't play a role, they're not casting shading or anything like that. I'm going to disable their room bounding property, and then I'm going to hide them, okay? I could delete them if I want, but of course that's not very BIM-like. If you're working in a separate model, that's fine too. I'm just disabling them so the energy model doesn't see them. So the next thing to do is do this visual check. So let's look around this model, and this model looks pretty good. But as we saw, you've already seen the little clue. Always look underneath the building as well, and you'll actually see over here, this is actually a pretty significant sort of gap or missing element, whereas this area isn't. So just to do this, there's one of two ways I can deal with general gaps in the building. In this kind of case here, it's really simple to just, fix it, right? In other cases, I could maybe draw a patch in, or maybe keep it in a separate linked model if it wasn't something that I wanted in the main model. Or the other trick is you can use conceptual masking. Sometimes if you've got models that have gaps all over them and you don't want to, like let's say there's an entire roof missing and you don't know how to model the roof, or there's maybe, because of the way the thing is modeled, there's holes all over it, you can just extrude a conceptual mask sitting inside the building, basically capture the shell of the building, and that will basically shrink wrap the whole building, and you can analyze the model from there. So one way or the other, it's very, very quick to do that. So from here, remember, I've already checked my energy settings, using that mode, the default resolution, and so on. I'm not using the perimeter zone because this is like a detailed model with interior walls. And I'm going to create this energy model. Now, one other tip I have here is that the default view that creates the energy model has some advantages to it, but I like to create my own. So I'll just close that, and I'm just gonna literally hijack my existing view. So just go in here, I'll create this one. This one is going to be the analytical version of it, right? So I'll just rename that. Okay, and this is what to do. I just said, this is the tip now. Set this to mechanical, because that makes the architecture nice and gray. Set the visibility and graphics to show me the analytical model categories, and I want the surfaces, and I only want the surface type shades, okay? So what we can see here is what I showed you earlier, where, up here, we're getting, all these shades are all in the right position, right? Any element that's sticking outside the building is not reasonably enclosing space is shade. And it's the same with these walls here underneath that roof. And like I explained earlier, if you look at that roof, you'll find that it's not set to room bounding. So sometimes that happens in model. People turn off things maybe intentionally or not. So all I'm going to do is I'm just going to generate the model again. And now we expect to see that because the roof is set to room bounding, there shouldn't be any spurious shades appearing in there. Okay, so let me open up the analytical model view again. So now we can see, the shades there. And if we were to do the other surfaces, for example, like you'll see actually, if you turn on roof, you'd see it's found where the roof is. Okay, and notice now you'll see that where, hey, there's gaps and so on. And so this is where I was making that point about just take a quick look at the main, exterior walls, fixed lights. You can create different views. I'm doing this all manually at the moment. But basically what you can see here is, if we look more closely, there are some missing elements here. And it's just a function. This is a detailed model, and we've got the default resolution. So what I'm going to do is increase the resolution. All right. So if I go in here, and I'm going to just jump down to 8 and 6. Sometimes if it's a very large model, this is essentially the same. Sorry, 8 and 4. This is the same effect of essentially doubling the volume. If you half the resolution, it's like doubling the volume. So this can take 8 times longer. Which again is another reason why it's good to remove any elements that don't play a role. So if I create this again now, you'll see when I create this, it'll take a little longer. It is noticeable. It's just not that much longer. This step in the process, if you've got a very, very large model, like millions of square feet and a high resolution, it can take, a couple of hours to do this step. But, remember that you're talking a couple of hours of processing time versus, versus days or weeks of manual energy model creation time. So it really does save, and you get a more accurate model. So let's take a look at the analytical model now again. And you can see now here, you can see those surfaces are a lot tighter. But again, when I check those shade surfaces, like I showed in the demo or in the slides, if I check those shades, there's some appearing here that shouldn't, and that's where I just go down here and say, okay, yeah, I'll take a closer look in that area. Fix it. And again, this people say, oh, I don't want to have to model things the way just because of analysis. This isn't right. Physically, this isn't right. This should be fixed, right? So that's just where, running this actually does help improve the quality of the model, the completeness of the model, or the buildability of the model, I guess you can kind of put it that way. So just one more time, let's delete that and create it again. At this time, I think if I've remembered everything, it'll be complete. So that's essentially the steps. You'll start with a default resolution, look for shades. Sometimes it can look terrible to begin with, and you realize there's large parts missing from the model, or they're on a different phase or something like that. But then once you resolve those differences and then get the resolution to the right level, you'll generally be able to get an energy model within a few % of the physical measures, which is really quite remarkable, because energy model creation is normally one of sort of simplification. So here we can see now all the shades are in the right places. It's even picked up that little roof parapet, which is a small detail, but you get it for free. And then if we look again at the exterior walls and so on, you'll see, let's just turn the whole thing on. Take a look at it. See, this is a very, very accurate energy model, including ceiling voids, everything. So that's the energy model creation step by step. It's 5 steps. You do it with any model. Depending on the model size and complexity and the state of it, it'll take you anything from a couple of minutes to maybe an hour or two. To create an energy model, it would normally take days or weeks to create. And once you've done it, you only have to do it once. Any changes in the model, it'll be able to pick that up and just work. So that's the energy model steps done. I'm going to go back to the deck now, and I'm going to get into the next part of this, which is essentially, oh, that was my demo, exploring the results. So once I've created that model, I can click generate an insight, and it'll send it to the cloud. It'll run the few hundred parametric simulations and send me an email that I can click the link on and open up the results. So this is Insight, and as I said, it's browser based. And what people don't understand is that when you first have a new model, they go to this uncategorized grouping. So Insight, think of it like a gallery, and they go into this uncategorized folder by default. But what you can do is you can go and you can create a new Insight, and then store your models as required, by project or design stage. And from then on, if you run that model again or update it, it will go to that place. Okay, so that's something that people don't always understand. It's a great way to organize things. So yeah, each one of those just is a unique one. You can assign a little picture to it so that you can recognize it and so on. When you get in one level into Insight, you look at the model menu. This is worth knowing because you're always organizing these things. So in the model menu, one of the basic things is just people don't always see this little 3-dot thing here. You can move models really easily. So move them into a different Insight folder. Okay, and because you can always be organizing these things, you can also rename and stuff like that. I'm going to come back to this menu in a little while later on, but this is the basics of it. Now, one of the most fundamental things that you'll see when you get into Insight, and people ask me about this a lot, is should I use energy cost or energy use intensity, and what's the difference? Now, the default is energy cost. In other words, total annual energy use of the building that's being calculated divided by the floor area. So it's dollars, and you can set your own currency. I'll show you later. Per square foot per year. Okay, that's the default. And the alternative you can use is energy use intensity. And so that it's just click the little icon to switch between the two. That's all you need to do. Now, the reason we make cost the default is that energy modelers and engineers are used to working in EUI. They know what 29 kBTUs per square foot is. They know what's good and what's bad and so on. But most people can't put a value on that. They don't know what it really means. So if you're wanting to talk in the broader project team as to the value of different decisions and the impact it will have on energy savings and so on, energy cost is really a great way to do that. And again, I'll show you later on how you can set utility costs relative to the energy so that you can get that. But it's just a more human way to talk about it. And ultimately, it's the ultimate value. It's the actual value that the owner will get from some combination of decisions, configurations, right? The next thing is to look at the benchmark comparison. This is a key one, and this is the piece that causes the little dial to go from red to orange to green. So what you'll see here, there are 2 benchmarks. One is actually 90.1, and the other is Architecture 2030. And like I said earlier on, they're influenced by the building type setting. Based on the building type and climate zone and building size and so on, it will create an ASHRAE baseline. It will determine what that is. In this case, it's 92. And if your energy cost mean is above that, it will be red. If you're below it, it will be orange, as you can see here. And if you exceed Architecture 2030, it will go green. So the point here being is that in this case, we're looking at EUI. 53.4 might be good or average in this case in one climate zone, or bad or really good in a different climate zone or different building type. So to give you some sense of relativity of scale, the benchmarks are really useful to be able to say, where am I at relative to code, which is minimum practice, and 2030, which is best practice. And every building, climate zone, et cetera, being different, it gives you some sense of relativity. And there's not just a number. As I say, it's 53.4 good or bad. We have some sense, as we can see on the scale, to do that. I covered this a bit the last day, but again, it's because it's one of those areas that people, commonly overlook or don't fully appreciate. I'm going to talk about it again here now. But the Bim setting and this energy range paradigm is really, really important, right? So what we mean by the Bim setting, the Bim is whatever's in your Revit model. So your Revit model, your energy model geometry, like I just showed you, along with the location, along with any other data that's associated with that model, like thermal properties of walls, floors, roofs, windows, as well as space by space properties, if they're present or not, and schedules and so on. In other words, whatever's in your Revit model is what represents the BIM, the single point of performance. Okay, and that's simulated, but along with a whole series of alternatives. So for every factor that drives building energy, like glazing or roof properties, numbers, every input that people think about, we vary it so that we evaluate where your model is at, and we show you a scale of going, making it worse or making it better, and what impact that has on the overall. And so what that allows you to do is, from a single model, at any level of detail, quickly explore, what will make the building better or worse, or what would it take to get to net zero or so on, without having to build many individual models. Essentially, from a single model, I can turn that model, which has maybe 44% glazing, into 65% glazing very easily without having to remodel it. If that's something I want to do, then I can model it and go to the next stage. So that's a really critical thing, and people tend to overlook this and sort of dial into specifying the BIM setting without actually appreciating what these other alternatives and the range-based paradigm is actually doing for you. So one of the things I say to people, another tip is, explore opportunity and embrace uncertainty. A lot of existing tools, force you into thinking, I must specify all the inputs very, very, very accurately or precisely in order to get a reliable model, when in fact that's not the case. Every input has a different value and impact on the overall building energy. That's really what Insight does. So all these different factors, think of them as main decisions that you need to make, have any one of a number of settings that you can set. By default, when you run it, it'll start with a full range. It'll say, even though we run your BIM setting, you haven't set it in Insight, so there's a full range, and the energy range, min, max, mean, will all be a product of that full range. But from here, I can very easily say, well, this situation here is representative of if there's an unknown, and the example of that would be operating schedule of a building. If you were looking at a spec office, I would suggest you use unknown, because it could be anything from 9 to 5 to 24/7. You don't want to assume that it's going to be a single hour set of occupancy hours. But very quickly, like I said, without getting bogged down with sort of artificial precision, you can very quickly say, well, what will be the impact of a high performance range, a medium performance range, a low performance range? And you're going to see the impact on overall building energy without having to work very hard. So you can very quickly have a conversation and understand what matters and what doesn't, and help use it to drive decisions. Then, of course, there's the BIM setting. You can pick up the BIM setting. So if your window design is done and you're at DD and you're not changing it, you can pick it, and it's a known then, and you don't change it anymore. But again, the key point to notice is the fact that, let's say any other single point, let's say in this case I moved it down to the right hand side and my EUI changed by 5 kBTUs. Well, if I was to go back and make that change physically in the model, then if I ran it again, the BIM setting would have moved, right? So the new BIM setting would actually be taking the place of where the old one was. So this is the point. You don't always have to specify everything in the model. This is equivalent to having that data set in the model. And the point is, this whole range of factors really allows you very quickly from a single model to understand design opportunity, like, role of passive design, like whether it be orientation or glazing, shading, or whether it be more system side levels of efficiency, envelope properties and so on. Any combination of those things you can explore. And what I encourage people is that if you're in any doubt at all, use a range. Don't fall into the trap of moving towards, specifying something that you don't necessarily know for certain. Even early stages like window to wall ratio, you don't know you have 57%. You're more likely between 50 and 65%. It's more accurate, in other words, to assume a range than it is to assume a single point. It's more reliable basis of design until it becomes set and decided. That's really the key aspect of Insight that sort of differentiates it and makes it a very useful tool as part of the design process. Another aspect is to use scenarios and scenario compare. So this is really powerful. So a scenario is basically just a saved combination of factor settings. So if you look at Insight and you move the factors around any state, like you see this is the orientation set, the Bim setting, et cetera, and I click this little button up here, this little bookmark button basically, and I can give it a name and I can call this one code, and you'll see they appear in this menu. And that will save that set of settings. And then I can create another, I can move my bars around and I can save it, and I can create a different one. This one in this case is high performing, and you'll see that it creates that one. And I can flick back and forth between two. So I can have several different states. So again, a single model that I've generated, run in the cloud, and because I can move factors around, I can represent it. So like I sort of said, I don't have to go back to the Revit model and have everything embedded in the Revit model. I can just do that as an optional step of documentation if I want at a later stage. But the cool thing about this is that if I create these different scenarios like I have here, from essentially doing sort of nothing to improving the envelope, improving the, reducing internal loads, and then high performance HVAC, and then adding on some PV, you can basically see very quickly within Insight, just compare. So this is a step down, all the way down to hitting Architecture 2030 total building cost. And again, it really reinforces the whole point of Insight is not just to determine a single point in sort of space and time, but to help you understand, opportunities and differences and do comparison and make decisions. That's really the critical thing about it. So it's not just really energy analysis. This is why we talk about energy optimization. It's giving you the information to make better decisions as to what matters and what doesn't. And then the next piece in this is within Model Compare. There's a few hidden features in here that people sometimes often overlook. So the first one is just the settings, just on that little cog on the right-hand side. That's where you can set different units. So if you want imperial or metric, if you're using energy cost, you can set local currency. Also, you can set the utility rates, so the cost of gas and electricity in your local area. If you're within the US, that's automatically set based on statewide average, but outside the US, you need to enter that yourself. And there's also some options for how you sort the factors and widgets, by importance or in a fixed order. The next one, which is cool too, is the ability to share insights by email and also do some commenting. And the thing to note here is that although you need Revit to generate the insights, your Revit subscription or AEC collection subscription, you don't need it to actually access it. You just need an Autodesk ID. So if you email this to somebody with an Autodesk ID, like a client, you can share this with them and they can see for themselves what the performance would be, meaning, you can dispose of paper reports, and it makes it dynamic. It helps people understand that energy is a moving target. It's a function of a series of decisions. There's certain uncertainty in there, and your scenarios can basically be your recommendation of, the steps that you're going to take to achieve better performance. The other piece here to point out is that when we create all those different scenarios, like I said, code or, with better performing envelope, I can apply them to different model instances. So these models could be either different stages in the process or fundamentally different massing options, but I can still apply the same scenarios like high performing, co-performing, whatever, and I can do that comparison very, very quickly here. That's another very powerful way to work with the models and do comparison, again, without having to run lots and lots of individual simulations and manage them separately. And then finally, with the export options, there's sort of two groups of them. One is sort of the classic export around, the file format, the underlying files that have been used to run the energy simulations, being Energy Plus, Do2, or Gbxml. You can also export all of the graphics, that go into Gbxml. So if you want to take these out into a report and use Photoshop and present them in a certain way, you can do that. Finally, the other aspect of export that is worth pointing out is the connection to the AIA 2030 DDX. Now, again, this is something that a lot of people are still discovering. This is nothing specific just to architecture or architects. This is basically a really great way to track your firm or your organization's portfolio and its level of performance on all its projects. It's completely private. It's only for you and you see it. But basically, all you need to do it is up in Insight, go to Services. You'll see this ability to turn on the AIA DDX. You just need to enter what's called a firm and user key. And all you need to do is contact the AIA for that, right? Of course, you need to sign up to the 2030 commitment, but it's free. There's no cost to any of this. And then once you enter that, when you click on report to the AIA DDX, it sends it to the DDX, and the DDX is a web-based portal to be able to track all your projects at all different stages and their level of performance. So as you can see and track your level of performance. And then every year when the AIA publish their report on how the industry is doing, remember lots of engineers are using it as well, you're able to see how you're doing and your projects are doing relative to the industry standard. So it's a really cool extension to things that way as well. Like I said, it's not just specific to the US. It's not just specific to architects. It can be used anywhere. So there are all my tips for energy optimization and the insight side of things. The last one I'm just going to touch on because it's just too much to cover in here, and also somebody else got to give a big shout out to David Shear for putting this together. If you just Google Insight Lighting Workflow Tips and Tricks, there's a great post on the forum on lighting analysis, and it includes everything from the best practices for creating your model, how to manage materials, how to optimize the simulation speed and things like that, right down to running custom analysis and working with units and, all kinds of visibility, and then what to do with support. There's like about 12 bullet points in there, which are really, really great. Like I said, we'll probably look to schedule another class specifically, another webinar specifically to do with this. But I just wanted to at least cover that here to make you aware of that resource. And that's it. So I'm going to stop here. I'm glad I managed to just about stay on time. We've got about 10 minutes left. So,
Perfect.
Jad, do we have any questions?
Thank you so much, Ian. It was really amazing. A lot of tips and tricks, to be honest. So just for the audience, so this will be recorded again. Will be on the EP Hub. I just shared the link with you guys where you can find the recording. You will receive a follow-up email from us. And we have few questions in. If you can take a look on the Q&A section while I will be sharing few other links. So in the QA section, I can see.
Yeah, sure.
So maybe
so you're right, John. I think I counted over 30 individual sort of tips. I know it's kind of like a workflow, but I sort of went through them as, there's a thing to be aware of. So yeah, there's a lot in here. I'll start addressing the questions if that's okay, Jad.
Yeah, please do. I will share. Yeah.
Yeah. So you asked about when you don't assign rooms or spaces, does it assign perimeter and core zones? So again, it depends on whether you have the perimeter core zones checked, and enabled. If you do, it'll always create perimeter core zones. And in fact, if you have rooms or spaces, it will even subdivide the rooms or spaces, but use the proportion of that data correctly. But I think the other part of your question is, does it find the room automatically? Yeah, even if there are no rooms or spaces, it finds what you call room, what we call the analytical space, based on any configuration of walls, floors, roofs, windows, ceilings, et cetera, that are reasonably separated from one another. So if you draw a box, 4 walls, a roof, and a floor, you'll get 1 space. If you draw a wall going through the middle of it, it'll create 2 spaces. It's super intelligent that way. Johan asks, can I save the analysis model from Revit to Gbxml? Yes, you can. I just touched on that at the end there around where to export it from. And so we're doing a lot of work with Gbxml at the moment on what's called a level 3 certification. So you can look out for that. In the next few months, we'll have some great documentation on that. Again, I'm just looking at these in the list. So this is great. Are you planning to add capability to dig into the results in more detail beyond EUR cost, hourly data, internal gains, energy use breakdown? Well, actually, it's all there. Actually, if you go to so let me just go here. So this is Insight we're seeing at the moment, and for each one of those models, there's a few hundred, like 250 something simulations, individual simulations run for each one, and you'll find them just by going to gbs.autodesk.com. So a lot of people ask about this. I covered this in the FAQs the last day. Green Milling Studio is still very much alive. We're not pointing people there as the place to try and draw understanding and meaning from. We're really just using it as the cloud-based service for running and storing the individual runs. Insight is a much more visual and interactive and understandable way to, make sense of all that data. Because if you go into any one of these and you look at it, you'll see, 250 runs. But each one I can go into and I can see things like the detailed breakdown, the energy use breakdown, basic assumptions, you know, the detailed view, and there's just a whole bunch of stuff in here that you can find. There's more, of course, that we plan to add as well. It's just where it's at the moment. One thing I always ask people though is that people are used to looking at, you know, that drill down, but often when you actually look at it, it's hard to make decisions based on that drill down, because let's say you reduce lighting energy, well, that's going to increase heating, and it's going to reduce cooling. So looking at those integrated effects, really looking at total building energy is the sort of the ultimate thing. But that breakdown is good for QA and making sure the model is working the way you want. Any other resources you can suggest to learn Insight? So yeah, there's obviously the online help, and there's also the Insight blog. So within Insight, you can find the blog. I'll just show you that very quickly. We haven't updated it in a while. We've kind of been really busy, but I just go to the blog. There's also the forum is really great as well. You notice Greenville last year was the last time we updated this, but there's a lot of good content here. And also just the Revit help, right, for what we call energy optimization. Are you planning to add capability, export full energy plus model so that work can be further edited in the software? It was just geometry. No, it's more than geometry. All the data is there now. And yeah, we're actually got a lot of really exciting stuff with Energy Plus in the pipeline. So we'll have more to share on that in the future. If my exterior walls don't show up when the analytical surface, oh, sorry, that just disappeared. Jad, I'm not sure what happened. Oh yeah, there it is, yeah. If my exterior walls don't show up when the analytical surfaces are turned on for exterior walls, does that mean my wall's not set up correctly? It doesn't not necessarily mean that your walls aren't set up correctly. You know, there's very little requirement for what's correct or not. First of all, if the wall doesn't show up, it could be one of two things. First of all, it's not set to room bounding. If it's not set to room bounding, it's just not going to be seen. Other than that, it should show up. If it's not showing up, but it's a small piece of wall, it could be the resolution, so you just need an increased resolution. But if it's not showing up, check if it's showing up as a surface type shade, because that means that there's some other gap in the model that means it's not being interpreted as an analytical surface type exterior wall. And then finally, there is a sort of a fringe case where you can have two walls that are directly connected or adjacent, but not quite parallel. And that's a little limitation we have at the moment. We call it non-parallel sandwiches, where it won't create a wall. And what you should do there is pick one of the walls and set them to non-room bounding, leaving just one wall. That's something we plan to fix. David, I hope that answers your question. If not, if you can send me a picture of it, you can use that email address that I'm hiding at the moment just there. I'd be happy to help you, or we'd be happy to help you. So let me know. And then different David, does it recognize design options, or would you need to use multiple models? So it recognizes the energy model is created from the main model, and so you can have your design options and you can swap them in one at a time, but it'll only create the model from the main model. So in other words, what it won't do is create the energy model from the main and then create 6 other models from each of the design options. That would be nice. We're not quite there yet with that. You need to create each model separately. So hopefully that answers that question. So that's it in the list.
Yes, so I'm trying to see if there are other questions on the chat window. So there is, I think that's good. We answered all the questions. I will take ownership here just to share my screen. Let me here. So I shared a few links, guys, on the chat window. So there is a link to register to the upcoming episode, episode 3, the practical example on June. So there is a link, you can register there. There is also a link to thank Ian for this presentation and to share the feedback. So
Chad, I'm not seeing anything. I'm not sure if you're
not
stop my share.
Okay. No. Let me share again. All right.
Just on that point, yeah, thanks, Chad. If anyone has any feedback, I would love to hear it, or further questions, contact us here. So I think it's, I got it now, Chad. Indeed.
So yeah, so you have the link on the chat window, so please use it to share your feedback and any requests you may have. So I will share it with Ian and with the team. So I shared also the link to the next episode. So feel free also to register there, and you will receive also a link to register again to this on the follow-up email. I can see maybe a chat window, maybe there's a question. The register link is not working. Okay, let me check again here. Oops. Okay, let me again see here. See, okay. I will try here again on the chat window. Yeah, so please use this one, guys. Thanks, John. I think the link was not, so now try to see.
Yeah, that works.
So it should work. So this one is the tips and tricks. The second one. Let me again.
Oh, that was the second one, yeah.
Yeah, let me see here. Anyway, you will receive it also on the follow-up email. So we will see also the link to the register. So I'm just trying to see here. So if there is any question, guys, feel free now to ask it. So since Ian is with us, I'm trying here. June. Yeah. All right, so I have the link. I'm sharing it now. Thank you, John, again for noticing this. So yeah, so this one should work for the episode 3. Yeah, so you can register, guys. So if there is no question, thank you, Ian, again for your time and for sharing all these tips and tricks. It was really interesting for all of us. Thank you to all for your time and for your engagement. Feel free to reach out if you have any question or feedback. And again, you will receive all this on our follow-up email. Thank you all, and see you in the next episode on June. Thank you again.